Hi, today I'm going to discuss about a very controversial subject, that is methane, the methane gas I'm talking about. Recently in Tamil Nadu, there are proposals to extract methane from the underground, especially in Neduvasal village in Pudukkottai, also in Karaikal. This has created a lot of controversy among the public. First of all, methane is a good gas and also it is very bad. We burn natural gas and it warms your house. We are burning methane all the time and it warms our houses and our schools and our churches. But when it leaks from fracked wells or the melting Arctic, and it warms the whole planet. Actually, enormous amount of methane is being released from Arctic tundra. So methane has been pointed out as a very potential gas for global warming. Actually, methane is more powerful than any other greenhouse gases. For example, carbon dioxide molecule, one molecule is one machine gun. Methane molecule is 22 machine guns. It is known as the global warming potential, GWP. So in other words, methane is very, very dangerous, 22 times more powerful than carbon dioxide. And little amount of methane can have drastic consequences. So anyway, when you use in your house, methane is good, but when it is leaked into the atmosphere, I think it is very bad. And that is what we are talking about, that is what we are discussing about. And naturally occurring methane is not harmful, but the gas released through human activity, it can have drastic consequences. Methane is produced by the breakdown or decay of organic material and can be introduced into the atmosphere by either natural processes such as the decay of plant material in wetlands, the seepage of gas from underground deposits, or the digestion of food by cattle or human activities such as oil and gas production, rice farming, or waste management. Even the cow dung is a good example of methane. Decaying grass is methane. And you must have observed in a sunny day in the rice fields, a lot of bubbles pop up, and that bubbles is methane. So rice cultivation produces enormous amount of methane. Also our landfills, they produce enormous amount of methane. It is an everyday factor. Methane is an organic compound known also as acetylene or butane, containing only carbon and hydrogen and often occurring in petroleum, natural gas, coal, and bitumens. A hydrocarbon is a molecule whose structure includes only hydrogen and carbon atoms. Interestingly though, hydrocarbons once combined also form bonds with other atoms in order to create organic compounds. The presence of carbon is required for a compound to be classified as organic in all but a few cases, but the presence of a hydrocarbon adds even more basis for it to be considered organic, as there are a few inorganic compounds that do contain carbon but not hydrogen. The presence of a hydrocarbon in an organic compound means the bonds between the atoms will be particularly strong, unlike the bonds in inorganic compounds and in organic compounds that contain a carbon atom. The presence of other atoms leads to hydrocarbons being classified as either pure, only hydrogen and carbon, or impure, hydrogen or carbon bonded to other atoms as well as each other. Methane is a naturally occurring organic compound, but human activity has increased the amount of this potent greenhouse gas that goes into the atmosphere. Most of the methane that humans emit comes from natural gas, landfills, coal mining, and manure management. But methane is almost everywhere, and it comes from some surprising sources. Here are a few that you might not expect. The first is natural gas and fuels. Many of the natural fuel sources we use are hydrocarbons. Compounds like methane, butane, propane, and hexane are all hydrocarbons. Their chemical formulas consist of only carbon and hydrogen atoms in a variety of ratios and chemical configurations. The second example is plastic. Every day we see plastic. Many of the plastics we use in everyday life and in industry are made from long chains of monomers formed from petrochemicals. These petrochemicals are simply hydrocarbons of different chemical compositions. Then comes paraffin, the wax that we use for a variety of industries. Everything from candle making and food preservation to medical and industrial uses contains hydrocarbons. Isopropyl alcohol, the next example. This common medical chemical is interesting in that it contains a hydrocarbon that is then bonded to further carbon atoms. The initial hydrocarbon CH3, that is the chemical formula, bonds to other atoms to form CH3 to CHOH. The last example is asphalt, the common substance that most people are familiar with, is actually a hydrocarbon that has been heated to form the substance tar. It is then mixed with other key industrial ingredients to form the mixture that makes up the road's surface. Methane is the simplest hydrocarbon, a single carbon atom surrounded by 4 hydrogen atoms. It usually forms when larger organic molecules are broken down either by microbes or by heat. The microbes produce it when they eat dead plant matter in wet, oxygen-poor environments. They are the source of the methane bubbling up from Goldstream Lake, from swamps and marshes all over, from human-made rice fields, landfills, and manure lagoons, and from the stomachs of cows and other ruminants. Termites emit a lot of methane too. Most of the natural gas we tap for fuel, however, was formed not by microbes but by heat and pressure deep underground, as oil and coal were, and often in the same places. In coal mines, methane is an explosion hazard. In oil fields, it was long considered a nuisance to be burned off, or worse, vented directly into the atmosphere. Liquid oil was more valuable as fuel and much easier to transport to markets. Since 2005, gas production from deep shales has increased more than tenfold. It now accounts for more than a third of total production. And deep shales are not the last methane source. Scientists are trying to figure out how to tap the largest one of all, the methane hydrates that lie frozen under vast areas of seafloor and Arctic permafrost. Worldwide, hydrates may contain more energy than all other fossil fuels combined. Neduvasal in Pudukkottai district and Karaikal, they have enormous amount of methane hydrates under Karaikal ground and Neduvasal ground. In the Kaveri basin, full of methane hydrates, they abound. Neduvasal in Pudukkottai district, over 400 kilometers south of Chennai, is threatening to become the next hotbed of protest in Tamil Nadu. Farmers, villages, and environmentalists are protesting against a soon-to-start hydrocarbon extraction project, claiming that it will affect their farmlands and pollute underground water. Methane is extracted through a process called hydraulic fracturing, or hydraulic fracking, or hydraulic fracturing, or hydraulic hydrofracturing, or hydrofracking. It's a well stimulation technique in which rock is fractured by a pressurized liquid. The process involves the high pressure injection of fracking fluid, primarily water containing sand or other propellants, suspending with the aid of thickening agents into a well bore to create cracks in the deep rock formations through which natural gas, petroleum, and brine will flow more freely. When the hydraulic pressure is removed from the well, small grains of hydraulic fracturing propellants, either sand or aluminum oxide, hold the fractures open. Hydraulic fracturing began as an experiment in 1947, and the first commercially successful application followed in 1950. As of 2012, 2.5 million frac jobs had been performed worldwide on oil and gas wells. Over 1 million of those within the United States of America. Such treatment is generally necessary to achieve adequate flow rates in shale gas, tight oil, and coal seams gas wells. Some hydraulic fractures can form naturally in certain veins or dikes. Hydraulic fracturing is highly controversial in many countries. Its proponents advocate the economic benefits of more extensively accessible hydrocarbons. Opponents argue that these are outweighed by the potential environmental impacts, which include risk of ground and surface water contamination, air and noise pollution, and the triggering of earthquakes, along with the consequential hazards to public health and the environment. Increases in seismic activity following hydraulic fracturing along dormant or previously unknown faults are sometimes caused by the deep injection disposal of hydraulic fracturing flow back and produced formation brine. For these reasons, hydraulic fracturing is under international scrutiny, restricted in some countries and banned altogether in others. The European Union is drafting regulations that would permit the controlled application of hydraulic fracturing. So what are the objections raised by the villagers from Neduvasal in Tamil Nadu? Villagers are saying that agriculture will be heavily impacted if extraction begins. They are also apprehensive that fertility of the land will be affected and groundwater will be contaminated. There is also fear that there could be saline water intrusion if the seawater and groundwater interface is disturbed. Moreover, no agricultural activity can happen while the exploration is on, and villages in and around Neduvasal are completely dependent on agriculture. What are the risks and concerns of fracking? The first is contamination of groundwater. People have less water there, that is the less fresh water, and that water will be contaminated. Saline water intrusion is going to take place. The second is methane pollution and its impact on climate change. When they extract methane, enormous amount of methane is going to be released in the atmosphere. Already global warming process is accelerating. Methane will accelerate very efficiently. The third is air pollution impacts. Already greenhouse gases are pumped up into the atmosphere, and methane extraction from Neduvasal and Karaikal can accelerate this process. Then comes exposure to toxic chemicals. Hundreds of chemicals are used for methane extraction. Those toxic chemicals will be further introduced to the atmosphere, which will cause health hazards. And then blowouts due to gas explosion. Sometimes methane gas can explode. Easily it can explode. Today in Arctic tundra, a lot of experiments show that they are very, very dangerous. And when methane is extracted from methane hydrates, explosions are inevitable. And the waste disposal, next is the waste disposal. There's a lot of waste being generated when you extract methane. Those wastes are going to cover a large surface area where agriculture is taking place. All these chemicals can go into agricultural productivity. Then large volume water use in water deficient regions. Actually, there is lack of water in Tanjavur district and Pudukkottai areas, and agriculture is already facing difficulties. And this project, methane extraction project, is going to happen in those areas. It is going to have disastrous consequences. Then comes fracking induced earthquakes. Also, earthquakes are possible because you are disturbing the fault lines under the methane hydrates. And when you inject enormous amount of chemicals and water, and when you shake the underground, earthquakes are inevitable. Workplace safety, people were living in safety in those areas, but people, those who do agriculture, they are exposed to dangerous situations. The last one is infrastructure degradation. So the infrastructure is degraded, and all the people, those who live in society, schools and churches and farms, all will be degraded because of methane extraction. So I think Tamil Nadu people are protesting it. That's a good response, and we need to stop this project. If they want to extract methane, they can go to Arctic region or Antarctic region, and especially in Siberia. There are plenty of methane is available. People looking for a large amount of methane, these are the places to go where people also, they don't inhabit there, and there are no houses, there is no agricultural farms, but plenty of methane. So in order to extract methane, we need to go to places where humans are not living. We should go away from human settlement and agricultural activity, because a small amount of methane, you are destroying agriculture and the lives of the poor people. You can extract large amount of methane by not destroying agriculture, by not destroying poor people. So please go to Siberia, please go to Arctic tundra, please go to Alaska. We will get 1,000 times more methane than this poor people from Neduvasal or in Karaikal. Keep on fighting. Thank you.